AOPS Volume 1, The Basics. Number 15. Given log base 32 is equal to 0.631, find the smallest positive integer of a such that 3 to the a power must be greater than 2 to the 102 power. And once we're dealing with word problems like these, where the problem gives us some information to use from, it is always 99.99% of the case to utilize the information given to solve the issue that we're trying to solve for. So in this case, we're trying to solve for 3 to the a power must be greater than 2 to the 102 power, the smallest integer of a. So try to utilize log base 3 of 2 in order to solve this inequality. And to do so, to incorporate our given information, we must apply a logarithmetic property for inequalities. If we have an inequality such that a is greater or less than c, but I'm going to use greater than for this example, if we take the both sides the same log, this inequality remains the same. So if we take log base n of a, it will be the same thing as greater than log base n of c. This inequality won't change if we log both sides by the same base. So we can apply that for this example. So 3 to the a power is greater than 2 to the 102 power. So let us take both sides log base 3 to try to utilize our given information. So this will be equal to log base 3 of 2 raised to the 102 power. And now we can utilize another logarithmetic equation, or formula rather, that the log of base n with another integer b raised to a power such as c will be equal to if we put the power in front of the log, c times log n b. So we can apply this for the both sides of this in this inequality. And this is supposed to be a greater sign, not a equal sign. So a times log 3 must be greater than 102 times log 3. Log 3 is nothing more but 1, therefore a is greater than 102 times log base 3 of 2. And we see here that we're given that log 3 of 2 is equal to 0.631. Therefore, we can apply it to this term that's present within an inequality to solve for a. A must be greater than 102 times 0.631. And if you did some arithmetic and multiplied it out, a must be greater than, I already did this beforehand, must be greater than 64.362. And since we're asking for the smallest positive integer of a such that the inequality is true, the next closest integer to this quantity is 65. The solution to this question.